Hey everyone, welcome back from your extended vacation. So, before spring break, if I can remember, we were getting ready to start page 8. We had just went over the properties from the rational exponents. I did post a copy of these blank notes on Canvas just in case anybody lost them. So that link is on Canvas on the Monday, April 6th page. So I thought since we really haven't done enough to do problems on the practice test, we would just start out by reviewing the exponent rules. And once we do the next page, then you'll be able to go ahead and work on some problems on the practice test. So just as a review, property of exponents, remember it doesn't matter whether the exponents are whole numbers or fractions. They follow the same rules, so when we're multiplying and the bases are the same, we keep the base and we add the exponents. So here's an example, and as I told you before break, this one is on your test. So notice the bases are the same, x and x. Because there's no symbol there, we can assume it's multiplication, and like the property says, in multiplication we add our exponents, so 1/3 plus 4/3 is 5/3. And then dividing like bases, we keep the base the same, and we subtract the exponents. So a stays a, and then we do m minus n. So an example I put here, which is also on your test, x to the 3/5 divided by x to the 1/5, keep the base of x, and then do 3/5 minus 1/5, which is 2/5. Raising to a power, we learned in chapter 4, when it's raised to a power, which means there's a power outside parentheses, we multiply the exponents, so the base stays a, and then we do m times n. So look at all the different operations. Multiplication we add, division we subtract, raising to a power we multiply. So the example I put over here, 2 to the 1/3, raised to the 1/2 power, because it's a power rule. We multiply, 1 times 1 is 1, 3 times 2 is 6. So that comes out to be 2 to the 1/6, which remember means the 6th root of 2 to the 1st. So if we change that to a radical, that's what it would look like. If you have a product inside raised to a power, you just distribute that power to each of the factors in the product. So a to the m, b to the m is what we'd get. So same thing here. 9 y to the 1/2 means 9 to the 1/2, y to the 1/2. But we learned in class that 9 to the 1/2 is really the square root of 9. And that is 3. Hence the 3 here. And then we keep y to the 1/2. So don't forget that. Anytime you have a number raised to a power, that's just a fractional power. That's just indicating that that's a radical. So the denominator is the index, square root. The numerator is the power. So if you want to put those in just to see where they went. So it's the square root of 9 to the 1st power. Square root of 9 is just 3. Quotient follows the same rule. If you have a power outside and there's a quotient inside, that power gets distributed to both pieces of the quotient, the numerator and the denominator. So a to the m over b to the m. So 4/25, all raised to the 1/2 power, means 4 to the 1/2 over 25 to the 1/2. And remember, 4 to the 1/2 is really just the square root of 4, which is 2. See the 2? And same thing with the denominator. 25 to the 1/2 is just the square root of 25, which is 5. And then you can see that there in the denominator. So a number raised to a fractional power just means turn it into a radical and evaluate. And last, Negative exponents, remember whatever's inside, we just flip it. So this is a over 1. To make the exponent positive, we turn it into 1 over a, and then the exponent's positive. And that's 1 to the m over a to the m, which is just 1 over a to the m. And you can see that. You don't really need to do this step. You can go right from there to there. We flip it, the power becomes positive. So here's an example. There's one pretty much like this one on the test too. So my base is 8. To make that exponent positive, I need to reciprocate 8, and the reciprocal of 8 is 1/8 to the, now it's positive 1/3 power. And again, this is what your head should be saying, oh, that means the cube root of 1/8. So the cube root of 1/8, because the denominator becomes the index, the numerator is just the power. So the cube root of 1 is 1, the cube root of 8 is 2. So there's where the answer 1/2 came from. So every time you see a number raised to a fractional power, turn it into a radical and evaluate. And then just like in chapter 4, anything to the 0th power is 1, not 0. And remember, you can type it into your calculator and your calculator will tell you that. Okay, so hopefully that refreshes your memories from before spring break. So now let's go ahead and turn to page 8 and work some problems that use these properties. And just FYI, there are 4 of these on the test. Before break, I told you to highlight all of page 8. So everything on page 8 should be highlighted. So let's go ahead and turn to page 8. So these 3 examples, all great ones to study for the test. Let's just highlight the problem. I think a lot of you already did this, but we'll just start again. So all 3 of those, and then these are just different examples of those, so I would highlight all 3 of these too. And you'll see problems that look just like these are on page 2 of your practice test. So after we're done, I'm going to have you work a couple of them on your practice test. At the end of the chapter, when we finish, I'm going to have all the problems on the practice test worked out for you with a video. Every once in a while, if we have some extra time, I'll go through and do them with you just as a review. But I will have a video of all the problems worked out on the practice test before we take our test. Okay, so let's take a look at these problems. So the first example, there's no sign, so that means multiplication. In multiplication, we learned on the other side, you keep the base and you add the exponents, 1/3 plus 1/5. This is the step I require on your test. That's your work step. This you don't need to do because I know you have a calculator and you can use the calculator. But I need to see this because I don't want you to go from here to here and me go, wonder where they got 8/15ths from. So you have to show me what rule is being used. Multiplication, we add our exponents. Then you can go to this. So just to refresh your memory, we just type in, because we're adding, multiplication says add the exponents. Just do 1 fraction bar 3 plus 1 fraction bar 5, and you can see where they got the 8/15ths. Okay, so as long as you show me that step, you can do the rest on your calculator, but I need to see that step. That's going to be 2 points on your test. That's going to be 2 points on your test. So show me what you're doing on the calculator and then just plug it in. So super easy problem, easy 4 points. Okay, let's look at B. B is a division problem. So keep in mind, in division, with our exponents, we have to subtract. So notice how I'm showing the steps out here. 4/8, that simplifies to 1/2. X's, because it's division, we subtract. So x to the 3/4 minus 7/4. Y, 1/2 minus 2. And order matters, so do not switch the order on those. It's the numerators exponent minus the denominators, numerators minus the denominators. So again, you can just do these straight on the calculator. Just type in, I think this one you guys probably got under control, but just to show you, 3/4 minus 7 fraction bar 4. That's where they got the -1 over here. And then do 1 fraction bar 2 minus 2. And it's -1.5. And you guys all remember how to change it to an improper fraction on your calculator in your head? Because you can't put a mixed number as an exponent. You will never see an exponent that's a mixed number. So right here, if you look above this key, let me see if I can zoom in here. It's not getting too big. So this is A, B over C to D over E. That means change a mixed number to a fraction. So if you look above that key, that's what that means. So I hit second fraction key, enter, and it changes to the -3/2. Then we learned in chapter 4, anything with a negative exponent has to move to the denominator. So both of these have negative exponents, so that one needs to move down with the 2, and this one needs to move down with the 2, because they both have negative exponents, and to make them positive, you have to move them down. So it's 1 over 2, x to the first, y to the 3/2. Because remember, when you move them down, then they become positive. So product rule, quotient rule, now we have the power rule. How do I know it's a power rule? Because there's parentheses, and outside those parentheses, I have a power. So power rule, if you remember from the other side, means multiply exponents. So here I showed you the step. This is a step that I would need to see on the test. And then you can do this on the calculator. But show this step. Show me that you know power rule means multiply. So -4/5 times -1/4, y to the -7/4 times -1/4. And then like before, after you get that step written out, then you can just do it on your calculator. So -4/5, so -4 fraction bar 5 times -1 fraction bar 4, and I get 1/5. And you can see that's what they have there. Then you do the denominator, -7 fraction bar 4 times -1 fraction bar 4, and that is 7/16. So super easy as long as you remember your exponent rules. So show me that you're multiplying because it's a power rule, and then type it in your calculator. There's your answer. And you have 4 of those on the test. So make sure you study page 7 and all the exponent rules that we just went over. So 4 problems out of 22 are from this section. Okay, so let's practice on some. So number 5, I see 2 parentheses side by side. There's no powers outside, so I know this is not the power rule. But 2 parentheses side by side, remember, means multiplication. So if you want to put a multiplication sign there just to remind you, that would be great. So then we multiply our front numbers. So coefficients, 4 times 6 is 24. And what do we do with the exponents in multiplication? Add 1/4 plus 3/2. So like I said, make sure you show that step. That's your work step, and that's half the points. So the coefficients, the numbers in front, are multiplied. The exponents are added. Now you can do the rest on your calculator. So we have 1/4, so 1 fraction bar 4 plus 3 fraction bar 2 equals 1 3/4, but we can't have an exponent that's a mixed number. So we do second fraction key, enter, and that tells us it's 7/4. So then we go over here and write x to the 7/4. And make sure you put those exponents up in the air. That 7/4 should not be down on the ground. It's an exponent, so it needs to be up in the air. And that would be your answer. So see, these are pretty easy as long as you know your exponent rules. Okay, this is division. So in my head, I'm going division, division. What do I do with the exponents? That's right, subtract. So 54 divided by 6, the coefficients get divided, and then the exponents get subtracted. And like I said on the problems above, you have to keep the order the same as it is. Numerator's exponent minus denominator. So that would be 3/2 minus 1/3. So show me your work step. That's it. Divide your coefficients, keep the base the same, subtract your exponents. So then we type that in, 3 fraction bar 2 minus 1 fraction bar 3. Oops, another mixed number. So we hit second fraction key, 7/6. So our answer is 9x to the 7/6. And it says write your expression, use the properties to simplify the expression. Okay, there we go. So we are simplified. Okay, so product rule, quotient rule. So what's left? The power rule. So powers, remember every single thing. When we were doing in chapter 4, I told you if anything doesn't have an exponent, then write that. Just to remind yourself, yes, that 1/2 needs to go all the way across. So I'm going to show you 2 ways to do this one. So power rule, if you look on the other side, that's when we multiply our exponents. So this would be 100 to the 1 times 1/2, and x to the 6 times 1/2, and y to the 10 times 1/2. So all the exponents have been multiplied. And remember, if something doesn't have an exponent, put that 1 in there. So this is 100 to the 1/2. Half of 6 is 3, so this is x cubed. Or if you can't do it in your head, do it on your calculator, but you should be able to do that in your head, I hope. Half of 10 is 5. So now I say, am I done? So remember what I said about numbers that have fractional exponents? We should think of it as a radical. So this is really the square root of 100 to the 1st. And what's the square root of 100? Well, let's go ahead and write this. x3, y5. So the square root of 100, what times itself gives me 100? 10. So I would get 10x3, y5. So that would be the answer for that one. So that is probably the more difficult way to do it. Most students do it that way because on this section on the test they're like zoned in. Oh my gosh, these are the exponent rules. Got to use the exponent rules. But me, when I see this, I go, oh, 1/2 power. That really just means square root of everything in that parentheses. And then you can do the problem in one step. So anytime it's 1 over something, that's the index. So the index is 2, and it's all raised to the power of 1. And then I can just go down the line and take the square root of each one separately. So square root of 100, like we said, is 10, because 10 times 10 is 100. And then we learn to do 6 divided by 2, x to the 3rd. 10 divided by 2, y to the 5th. Boom. Same answer with very little effort. So So if you pick up on that, if that's a third, put it under index of 3. If it's a half, put it under index 2. And then you can just go straight to square root and cube root. So quite a bit easier, but like I said, most students don't pick up on that. You know, they're really working on the exponent rule thing, and we get the same thing, just a little bit more work. So let's look at number 8. Number 8 is use properties of exponents. So what property is that? It's a power outside, right? And this is division. That was a power of a product. This is a power of a quotient, but it's the same rule. You still multiply the exponents anytime it's the power rule. So this would be your work step for the test. M to the 7/9 times -4 over 7 over n to the 1/4 times -4 over 7. And so you can go ahead and do those on your calculator. I'm just going to do them in my head. The 7's cancel, so it's m to the -4/9. And here the 4's cancel to be 1. 4 divided by 4 is 1. A positive times a negative is negative, so n to the -1/7. And remember that rule in chapter 4 that said we're never allowed to leave negative exponents in answers? So this base and its exponent need to move down, and this base and its exponent need to move up to make it positive. So basically we're flip-flopping since they're both negative. So my final answer would be n to the 1/7 over m to the 4/9. Now the exponents are positive. Now we can stop. And like I said, if you can't do that multiplication step in your head, that's fine. Just type it in your calculator, but I just used rules from chapter 6. When we're multiplying, we can cancel common factors. So on the cross products, so 4 goes into 4 once, 4 goes into 4 once, so 1 times -1, -1, 1 times 7, 7. And same thing here. 7 divided by, or the 7's cancel. 7 divided by 7 is 1. And so I get 1 times -4, -4, 9 times 1, 9. And then again, we have to switch them because we're not allowed to leave negative exponents. So before you do the next lesson, well, we still have 2 problems to do on the other side, I think. But now you're ready to do problems 11 through 14 on the practice test. I think it'll be easier for you if you do them as you go. And then at the end, you can check them. Like I said, I'm going to post a video with all the problems. But this way, they're fresh in your head when you go to do them. So I would pause this video and go and do 11 through 14, or do the next page and then you can do it. Okay. So let's go ahead and go to page 9. Guess there's 3 problems here. I think we can probably let's just do 9 and 10. That should be good. So the algebraic expression 0.07 or 7/100 d to the 3/2. And this, you'll see, these are just calculator exercises. So you're going to plug a number in and then type it in your calculator. Describes the duration of a storm in hours. So we know that D is duration in, or no, the answer is the duration of the storm in hours. And the diameter, D, is miles. So this is the diameter, D, and it's in miles. Use a calculator to determine the duration of a storm with a diameter of 12 miles. So 12 is going to be our D. Notice it does say round to the nearest hundredth, So that's something else you should, let's highlight it instead. That way we don't have so many things going on. So that tells us once we get it in the calculator, then we're going to round. So diameter is D, so we put 12 in for D, so rewrite your problem and then you go straight to the calculator. So 0.07 times 12 to the 3/2. So that's what we have to type in the calculator. There's a couple things I like to remind students. First off, this is an exponent, so remember you're going to have to add a caret. And I kind of like to add it on the paper, then I don't forget to type it. And when it's a fraction or a negative, you're supposed to put your exponent in parentheses. So I would add that in too, and then it's all ready for the calculator. You got all the symbols in, now you're just going to type it like you see it. So let's practice this one. And then remember, it's rounded to the nearest hundredth. So 0.07 times 12, and then because it's an exponent, we hit the caret. And because it's a fraction, we need parentheses around it. So 3 fraction bar 2, close your parentheses. So you can go backwards and check it and make sure it looks like your problem. 0.07, that looks good, times 12, caret, and then your exponent is 3/2 because it's more than a single factor. We do put it in parentheses, hit enter. So let's write our first. So 2.90984 blah blah blah. And rounding to the nearest hundredths. Remember, when we're rounding, this is tenths, this is hundredths. So we say to ourselves, does that stay 0 or does it become 1? Only choices. Underline the place value and then ask yourself if it stays that or goes up 1. Those are the only choices. Because it's followed by a 9, it's going to go up 1. So we'd write approximately 2.91. And then we have to decide what the label is. All word problems have to have labels. So this was diameter. This was the duration of a storm in hours. So approximately 2.91 hours. So if the storm has a diameter of 12 miles, so imagine this round storm area, if its diameter is 12 miles, according to this formula, it's going to last about 3 hours, not quite 3 hours. So that's not bad, right? You plug it in. So this is really just learning to use your calculator. Okay, shall we do the last two here? I guess we can do 11. This is easy enough. So the annual inflation rate expressed as a decimal of a home that increases from P1 to P2. So the value from P1 to P2, that's important. Rate of inflation, that's what this formula stands for. N is years. Here's the formula, and don't forget that -1. It's really easy to forget that. So calculate the rate of inflation. That means I'm trying to find I for a home that increased from 180 to 350. So look at this. The first one listed is P sub 1. So this is going to be P sub 1. The second one listed is P sub 2, because we keep it in the same order it says, P sub 1 to P sub 2, P sub 1 to P sub 2, over a period of 10 years. Years we can see is in. This one says hundredths also, so let's be sure, and that's a good thing to highlight to remind us what we're rounding to, because once they give us permission, then we can do it. So let's go ahead and write our formula. So I equals, so P sub 2 we just said was 350,000 over P sub 1 is 180,000. To the 1 over n. N we said is 10, so we'd say 1 over 10, and then minus 1. So let me scoot this up a little bit so we're more centered. So P sub 2 was 350, P sub 1, 180. I put it in parentheses just like the problem. The n was 10, so I went 1 over 10, and then we have the subtract 1. So right away I go, oh, that's a busy number to put in the calculator, but I think, ding, 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 ding. Look at that. So then we don't have to plug all those in, because as long as you cancel the same number as 0 in the numerator and the denominator, you get an equivalent fraction, and something much easier to type in the calculator. So let's just type this in. And then remember what I said, you might want to put your caret in to remind yourself the next number is an exponent. And it's a fraction, so let's put our fraction bars in to remind us that we need that. And then last but not least, subtract 1. So we are ready to put that in the calculator. So parentheses 35, and you can either do fraction bar 18 or divided by 18. It really doesn't matter because we're rounding, so I'm just going to hit divided by 18. But if you wrote fraction bar, that's fine. And then close the parentheses. Then there's our hint. Don't forget the caret. And then we open the parentheses. We can either do 1 fraction bar 10 or 1 divided by 10. I'm just going to stay consistent and do divided by. So that tells the calculator that's the end of my exponent. And then I hit subtract 1. And I is 0.06875, on and on. So let's read what the problem wants us to round to. Hundredths. So I go to the hundredths place, tenths, hundredths, and I ask myself, does this stay 6 or does it become 7? Those are my only choices, and because it's followed by an 8, it becomes 7. So now we put the squigglies to show the reader that it is an estimated answer now, not exact. So approximately 0.07, and that's the rate of inflation. Because it says calculate the rate of inflation. Uh-oh. Out of room here. And really, rate of inflation is a percent, so I'm hoping it didn't tell us to change to a percent, that you understand that is a 7% rate of inflation. They told us to keep it as a decimal, but I'm hoping from your previous classes you understand that that means approximately 7% is the inflation rate. But in this case, they wanted that form. Okay, shall we do the last one? So, the speed that a tsunami can travel is modeled by this equation. So let's go ahead and write the equation. S equals 356 d to the 1/2. S is the speed in kilometers per hour. So if they give us a speed, we're going to put it in for S. If they give us d, which is the average depth of water in kilometers. So if they give us the depth, we'll put it in for d. If they give us the speed, we'll put it in for s. They're only going to give us one, so we just have to read. What is the speed? That means we're solving for s. when the average water depth is 0.512 kilometers. So that is our D, because it says right there, average water depth. So in place of D, we need to put 0.512. So S equals 356. Going to be a good idea. Put your time sign in or parentheses. 0.512. Because remember, there's an imaginary time sign right there. And then that's to the 1/2 power. So let's put our little reminders in. This is an exponent, so put that caret there to remind you to use the caret symbol. And then because this is a fraction, it should be in parentheses. The reason I have students do that is lots of time I'll look on students' calculator and they'll do 0.512 times 1/2 instead of to the 1/2. So that's why I always write it in, then you don't forget it when you're typing it. So let's see how this looks on our calculator. So 356 times 0.512. So far looks good, right? 356 times 0.512. Then I'm going to do caret, parentheses, 1 divided by 2, close my parentheses to show I'm done with the exponent. Hit enter. So again, we have round to the nearest hundredth. So that reminds us we need 2 decimal places. So S equals 254.7328 and on. So 356 times 0.2, 254.7328. So then we underline the hundredths place, 3, and the only question we ask ourselves is, does it stay 3 or become 4? And because it's followed by a 2, that means it stays 3. So now our symbol changes to squigglies to show the reader that it's no longer an exact answer. Now it's approximate. So 254.73. And then our last step, as always on word problems, is to finish labeling your answer. So what does S stand for? S is the speed in kilometers per hour. So you'd say kilometers per hour. And that would give you your final points. So those problems on Alex will just be plug and chug problems. They're just testing to see if you can type it into the calculator correctly and know how to put the correct labels on. So that's the end of 6.2, so you can finish up all your 6.2 problems in Alex now.